As we continue with motion problems, we're going to look at some distance, rate, and time, which should be familiar. Obviously, rate times time equals distance. That should be a known algebraic equation at this point. But we're going to look at some motion problems, some that we should be familiar with. Round trip, opposite direction, different distances. So round trip just means that I have gone one and I am going back the other direction. Or you could have two people leave at different times. They meet up at the same place, but it takes them different times to get there. Opposite direction or even meeting in a place means that you have two different distances, but they should equal the total distance apart. And then you could have different distances, whereas you have something else for one of the movements, and the other one is a different distance based on the time and rate at which they traveled. So this first example, Ted and Jeff planned to leave from the church at 9 a.m. to go camping, but Jeff was delayed until 9:30 by driving an average of 8 miles per hour faster than Ted. Jeff arrived at the campground at noon, the same time as Ted. What was the average rate of speed for both Ted and Jeff? And so I always recommend setting the chart. You have rate, time, and distance here. We do not know the rate of either of them. And so you have to pick one. We know that we can just put a variable when we don't know. So we're going to put a variable R for Ted. We also know that Jeff drove 8 miles an hour faster. So we're going to put R plus 8 there. The reason we know this 3 hours is because they tell us what time they left. Ted left at 9, got there at noon. That's 3 hours. Jeff left a half an hour later. That's 2.5. We're always going to multiply across. Rate times time is distance. Rate times time is distance. And of course, you want to keep this in parentheses because you're multiplying the whole thing. What we also know is that they started at the same point and ended at the same point. So these two distances are the same, which means you set them equal to each other. Once you set them equal to each other, you're going to do your basic equation solving, distribute that. We're going to move our variables to one side, numbers to the other, and divide. And we're going to have that rate that we were looking for was 40 miles an hour. Now, keep in mind, if they want the rate of both of them, we have really only solved for Ted's rate. And so Ted's rate we know is 40 miles per hour. But for Jeff's, we're going to go ahead and add that 8. So we know Jeff drove 48 miles per hour. And so these are your basic distance, rate, and time problems. Um, Most of them will be set up where they do equal each other. You could have ones that were set up where they are a distance apart and they meet. And so as you think about these, this particular one was they started at the same point, they ended at the same point. So here my distances will equal. If they start at the same point and go different directions, those will not equal. You're going to say they are the total distance. There may be situations where you have a round trip, as we talked about. Again, those distances will equal. But you can be giving any number of scenarios here and potentially come up with the type of problem you're going to want. You can always, however, put them in some type of chart. And so that's what you're going to want to do with these distance, rate, and time problems. The next type of problem you can run into with these are simple interest formulas. So when you look at this simple interest formula, the first thing you want to look at is the principal, that P um, is the amount of money that you are borrowing. R is the annual interest rate. T is the time of the investment. And L is the amount of interest that you are going to either get or borrow on a loan. And so basic interest formulas are, if you look at this example, Mr. Jameson makes $904.50 annually on a total of 9,500 invested in two accounts, one paying 9% annual interest and the other paying 10.5% annual interest. How much is invested in each account? And so when you think about this particular one, we are trying to look at two different accounts, and we do not know exactly what he has invested in each. We just know the total amount invested. And so you are again going to make a type of chart. You have one account paying 9%, one account paying 10.5%. We do not know how much he invested in the first one, so we're just going to put an X there. But if he invested, a certain amount of money, then if we take the total and subtract it, we should get what he invested. You do want to convert those rates to decimals. So you do want to put that rate as uh, 0.09. Um, in this case, it's an annual interest annually. And so total number of years, we're going to say one because they've told us an annual. And so to get that interest, we're just going to multiply across. We are going to say that the principal multiplied by the interest rate times the time is going to be how much he earned. And so we are going to set this up. Remember that when you have um, that subtraction there, you want to make sure you put parentheses. But the interest he earned on each of the accounts will equal his total interest. And so we would just set those up as an addition problem, and that should equal the total amount that he invested. And again, you have a basic equation to solve. You should know how to solve it all out, distributing, combining like terms, and solving that he invested 6,200 in the 9% account. Now, again, we do not know both. They want both of these. This is the 9% account. To get the 10.5% account, we are just going to subtract that from the total invested, that 9,500, and we will get what he invested in each. And then the last type of problem you're going to run into in this section are mixtures. A fruit punch is made by mixing together an orange drink costing 89 cents per liter, a lemon lime drink costing $1.19 per liter. How many liters of each must be mixed to produce 30 liters of fruit punch, valued at $2.18 for a 2-liter bottle? And again, you're going to set up a chart. We have orange, lemon, lime, and a mixture. That's what these will always look like. We don't know how much of each, but we do know the total. Um, they told us they produced 30 liters, so our mixture will be 30. We don't know how much orange. Again, just like the investment, if we subtract it from 30, that will be the lemon lime. You're always going to have a price or a percentage. This will always be that column. You can leave it as decimals, or you can see here, we've just taken those decimals out and done cents. We have the cost of the orange, the cost of the lemon lime, the cost of overall. This column will never add down. The price, the percentage, those will never add, but these should. X plus 30 minus X is this. The total cost of the orange plus the total cost of the lemon lime should be the total cost of the mix. And so again, this really creates your formula. We have 89X, the 119.30 minus X equals the total cost. And again, you have something easy to solve, distribute, combine like terms, and solve that equation. This is just another example of a mixture. The chemist has 12 kilograms of 3% salt solution. How much water will need to be evaporated from the solution to obtain a 5% salt solution? So again, you want to label what you have. You have 3% water, and then your mixture is 5%. They tell you how much of the 3%, 12. They tell you the percentage, obviously, of the 3%, and you multiply across to get this. We don't know how much water, that's the question. We do know how much, what percent of the water is salt. Hopefully, if it's water, it's no salt. Again, multiply across. In this case, we are um, evaporating, so we should subtract this. We have taken that 12, we've subtracted the water. That's how much solution we have. We know the percentage. Again, you're going to multiply across. And as always, this creates your formula. This minus that, because we're evaporating in this case, should equal the overall solution. And so as we conclude this section, um, you're going to read through the types of word problems and really just, I would always recommend a chart. for these types of problems, and then just work your way across those charts to set up that equation and solve.